everybody, and welcome to our Protecting Our Ice and Ocean session here at Dynamic Earth in Edinburgh as part of Protecting Our Planet Day, or POP23. My name's Chris, I work here at Dynamic Earth, and I'm joined by Nadia, who is a marine scientist. I'll tell you a little bit more specifically about Nadia's work in just a moment. Before I do, I would just want to say I hope you've been enjoying your day so far, and we're going to get stuck into learning a bit about what some polar and ocean researchers do, and do some activities of our own as well. So on the website you might have already downloaded some resources, and they might be popped into the chat as well, about pressure in the deep. That's an activity that we're going to try out a little bit. So if you've got that equipment already, we'll be using that in a little while. Now, we are here in Discover the Deep, which is our ocean gallery at Dynamic Earth, all about researching the ocean and in particular the deep sea. But before I get stuck into talking about why we research our ocean, I wanted to show you a video which explains what we call ocean literacy, which is understanding our impact on the ocean and the ocean's impact on us. So we'll play that video for you now.
Our blue planet. Over 70% of the Earth's surface is covered by a vast ocean. Many ocean basins form one connected global ocean. It's the largest living space on Earth. It's where life is first thought to have evolved. The ocean is also our life support system. Always moving, the ocean distributes heat and nutrients on a global conveyor belt of currents. It determines our weather, controls our climate, and makes our planet habitable. The ocean supports a huge diversity of life. At the surface, billions of microscopic plants capture the sun's energy and form the basis of complex food webs. Most of the ocean is deep and dark, but it's far from empty. The deep sea teems and glitters with life, all the way to the very bottom. Yet only a tiny proportion of the deep has been explored. As science and technology advances, we're beginning to understand just how important the ocean is to our future. We are connected to the ocean in many ways, and what we do affects its ability to sustain all life on Earth. Our carbon emissions are making the ocean more acidic. The seas are warming. And the ocean is now changing at a rate that has never been seen before in Earth's history. Exploring the ocean helps us to understand what these changes mean and what we must do to protect our life support system. The future health of our ocean is in our hands.
So hopefully that video helped you understand why the ocean is so important and why we all have a role in protecting our ocean as well. Now, this is when I will introduce you properly to Nadia, who is a coral ecologist, and she is going to tell us a little bit more about the work that she does. Now, some of you have already submitted some questions for her, so in a moment after Nadia's explained what she does and the science that she does, I'll be able to ask some more of those questions, so keep them coming in. So, Nadia, do you want to tell everyone what kind of research you do and a little bit about the guests that you brought with you as well?
Yeah, hi everyone. So I'm Nadia. I'm a researcher at the University of Edinburgh. And today I've brought along some of the corals I actually research. So I research into tropical corals which live in warmer climates. Tropical coral reefs cover only 0.1% of the ocean floor, yet house 25%, a quarter of all marine life that we know of. So that's an incredible amount of biodiversity. So that's why they're really important to protect. They provide lots of food and lots of other resources for us. And these corals that I brought along today are some of my study animals. This here is actually the skeleton of what we call is a species called Stylophora, which is a bit of a mouthful. And this species, you can see, it's got all these intricate branches.
It does, yeah.
And when you're on the reef, this creates a lot of habitat for lots of nooks and crannies for fish and other invertebrates to live within. These corals that I research into, however, you can see they're not quite the same. They're not quite as branching.
No.
They're a bit more boulder-like,
Yeah,
a bit more
quite
round.
round.
Yeah,
Yeah.
exactly. But the thing about these species is they are more resilient to climate change. These guys, not so much, unfortunately. These guys are a bit more susceptible to temperatures rising in our oceans.
Right.
These guys, however, are actually much more resilient. And the ones that I research in particular, this more brown, drab one looking over there, and they're actually, it's called porites, and it can actually form some mobile corals that roll around the ocean floor. And because they roll around, they experience changes in temperature and lighting more often. And so they're more used to these sort of dramatic changes that we can see in the ocean.
Yeah.
Now, this means that there is some glimmer of hope for coral reefs in the future.
Great.
We often talk about coral reefs going to be, that they're going to be a thing of the past, and I don't believe that's true. I think there's definitely a lot of hope for the future that we can continue protecting them. The thing is, they're going to look a lot different to the reefs that we're used to. We're used to these kinds of reefs, and what we might get is more like this kind of a reef. Which does still provide habitat. It does still provide a lot of intricate things and food sources for all those species that we think of, just maybe not quite as much. And so we need to think about ways that we can help reefs to continue providing those habitats. Now, you might think, so these tropical reefs, right, far away from where we live here in the UK, so why should we really care about them? Well, actually, we have coral reefs much closer to home.
Surprise.
Surprise, yeah. We actually have reefs around Scotland and the UK, and we have a reef called Mingulay, which is just off the Outer Hebrides, and that is a deep sea coral reef. So don't exist in the bright light, exist in the dark and the cold. And you might be thinking, well, is there anything else living down there with them? Actually, do you like fish fingers, Chris?
Love fish fingers.
Everybody loves a fish finger
How
sandwich,
did you
right?
know?
Exactly, right? And these fish fingers actually come from species that live on deep sea reefs.
Really?
Yeah, absolutely. Things like cod and haddock, all the things that we think of, your battered fish and chips on a Friday night. Yeah. So without these deep sea reefs, some of the species that we rely on, that we get food from, are actually, we would lose them if we lost those reefs. And just like tropical reefs that are threatened by climate change, deep sea reefs are also threatened by climate change. Yeah, but instead of temperature, it's more ocean acidification that's affecting them.
Oh my goodness. Okay, so we've covered a
information
lot
there.
there.
Yeah,
So
a lot of
one of the biggest things, that's okay. One of the biggest things for me was learning that corals can move around. I guess I pictured just coral reefs as being quite static and what's the opposite of mobile? Sessile is the scientific word, right?
Yeah.
But learning that they can roll around like boulders is pretty incredible. So lots of information there, Nadia. Thank you. And we have got some questions that have come in. So one question. Let's start off with year 4 from Mossley Primary. Why do we need to protect our oceans?
Yeah, great question, because it's going to take a lot of effort for us to protect them. But when you think about what they provide, we are so connected with the oceans, like Hermione was saying in that video just there. And the oceans provide us with lots of food. They help to regulate our weather. So you might have noticed over the last year, the weather has been maybe a little bit wetter, a little bit like, a little bit more unpredictable. And the oceans help to regulate that temperature and the weather for us. 500 million people worldwide rely solely on coral reefs, never mind the deep sea fishing and things that we get. So it's really important because they provide a lot of things that we rely on. And without a healthy ocean, there wouldn't be a healthy land.
Yeah, that makes sense. And one of the other questions from Red Hill Primary School was why they're important for the health of our planet, but that covers that as well. Yeah, they affect life on land, they affect weather, so our ocean is essential for life across our planet to survive. And we have a question from Egerton, I'm not sure, a primary magpie class, which is how can we help to protect the ocean? Yeah,
I mean, there's lots of things that we can do in our day-to-day. First and foremost, carbon emissions. Now, I know we talk about climate change a lot, and we talk about how we can reduce our climate emissions, because the ocean acts as a big carbon sink, is what we call it. It absorbs a lot of that CO2 that we put up into the atmosphere. And so by doing things on a daily basis that can help to reduce emissions, that's going to make a big difference.
Yeah.
We can also like talk to our adults and talk to our friends and family and just raise an awareness in itself. Like things that you've learned today about the ocean, go away and talk to your friends and family about it, and just spreading that word.
Yeah.
Can do make a huge impact on how we can protect our planet.
Yeah, and that's something that we can all do. We can all go back and just communicate all of our thoughts and feelings about the ocean with our friends and family and people we know, so people are always talking about it. Now, I had a question for you. You were talking about the health of the ocean and the health of the life that lives within it. You mentioned ocean acidification. Can you explain what that is and why that might be a problem in particular for our corals?
Absolutely, yeah. So as I just mentioned, the ocean absorbs a lot of the CO2 that we've been releasing into the atmosphere. In fact, some estimates put it at about 25%, so a quarter of all emissions. And as it absorbs that CO2, that dissolves into the ocean and produces something called carbonic acid. Now, we all know that word acid, yeah? It's like, it's not very good for things.
Sounds like a dangerous word.
It's a dangerous word, yeah. Now, these coral skeletons are actually made of something called calcium carbonate.
Okay.
And they are alkaline. As the ocean becomes more acidic, these skeletons start to dissolve away. Now, this is particularly a problem in the deep sea ocean where it's getting more and more acidic. And all that habitat, you can imagine if this crumbles away, you're left with not very much habitat for all those cod,
no
haddock,
shelter,
all the things that we like to eat. And so ocean acidification is destroying the reefs by essentially making them crumble.
Oh, okay. So it's becoming a little bit more acidic and the coral just can't survive there. And that's got the knock-on effect for all the creatures that use it as habitat. Okay, that makes sense. Now let's have another question. We've got a question from Bilston Primary, 6 and 7. How many species would be affected by coral extinction? I don't know if we can give you a number.
That is a very tricky question because we're discovering species all the time. So as I said at the start of my little spiel, that the tropical coral reefs, never mind deep sea corals, we're not sure how much of the ocean floor they cover because we're still discovering them all the time.
Of course, yeah.
But tropical coral reefs cover 0.1%, a tiny bit of the ocean, yet house a quarter of all known species.
Wow.
That's thousands, hundreds of thousands possibly.
They are pulling their weight.
They are pulling their weight, yeah. They are really a big home for biodiversity. But as I say, we're discovering new stuff all the time, and some of these new discoveries are really important, like things that we're discovering with corals. We can actually use them in medicines to help cure diseases as well. So we want to protect them so that we don't lose these things before we've even discovered them.
Yeah, absolutely. It's a really good point that our deep ocean is so unexplored. There might be
we know so
more
little
coral reefs that we need to explore and learn about and protect.
Absolutely.
Oh, and I've got a fun question here. What is the average length of a coral?
Oh, now, this is the tricky question because a coral is really hard to describe because it's a very unusual animal. It's actually a symbiosis, which means a close relationship between the coral and algae that live within it, right?
Okay.
And then within this structure, what you have is thousands of tiny little polyps, little mouths that feed and create this colony of genetic clones. So, how do you define the coral? Is the coral the polyp, in which case, in this species, it'd be about 1 millimeter. Tiny.
Yeah.
Or is the coral this big colony? And these colonies can become meters across.
Right.
So, yeah, I would say the average length is quite hard to define, but I would say the range ranges from a few centimeters, millimeters, up to tens of meters. Huge, vast colonies. They're called the cities of the sea for a reason. We've got skyscrapers of coral.
Yeah, I mean, that's probably then about the length of some of the rooms that everyone's sitting in now.
Absolutely, yeah.
Excellent. So that's a great answer. Thank you, Nadia. And it got me thinking, if you've got the coral and you've got the algae, just looking at some of the coral in your tank, you've got some different colours there.
Yep.
So what colours are what thing? is that?
Very good question. So the coral itself, those little polyps that I was telling you about, they actually have no colour.
Oh.
Yeah, which is why when we see corals dying on a reef, they turn white. We say that they are bleached. Because actually what you're seeing is seeing through their tissue and seeing their white skeleton. So the colour comes from the algae that live within the coral.
Yeah.
So here we've got this green, you might be able to just about see it on camera there, this species up here which has more green colour, a bit more bright colour. That's actually the algae producing pigments that actually act as a sunscreen to help protect them from harmful UV rays. So just as your parents at home will say, make sure you wear your sunscreen when you go out in the summer, corals do the same thing.
Excellent. Yeah, they've already planned to protect themselves.
Exactly, yeah. So that's one adaptation that they've created to help protect themselves against harmful UV rays. But then you get these more drab brown species that tend to live in slightly deeper water, but the pigments that they have help to collect light when they're deeper down.
Right, okay.
Helps the algae to photosynthesize.
That's so clever. So coral is a lot more interesting than I'd originally ever given it credit for.
Yeah,
so.
it's quite a clever rock.
Yeah, amazing. So thank you so much, Nadia.
You're welcome.
And thank you for sending your questions in. Now, we've talked a little bit about the deep sea in particular, as well as the range of different environments that coral live in. I want to touch on the deep sea for a little bit longer, though, with our activity that we've got planned. So what I might ask, Nadia, is can I please get a syringe and a marshmallow? And you might be preparing this in your classrooms. Perfect. Thank you. I will take those both. And can I please give you my cards and my iPad? Thank you. Okay, so I've got my hands free. So this experiment is one where we are going to learn a little bit about the pressure that some creatures face in the very deep sea. So if you have a marshmallow, you might want to pop a little face on it. This is going to be your deep sea fish. So if you've got a pen, you can pop a little face on your marshmallow now. When your deep sea marshmallow fish is ready, you are going to... Oh!
Good noise.
Good noise, yeah, the best bit. Not the best bit, there's lots more fun to come. You can pop your marshmallow fish into the syringe, and then you can put the plunger back in and push it down, but don't quite touch the marshmallow, okay? So it's just above, just about here. Now, to change the pressure inside the syringe, what we do is cover the end up, and it can be a bit tricky to hold it and cover the end up, so you can get someone else to help you if you like. You then, when the end is covered up, pull on the plunger. Now, I don't want to do it too much so I can give you a chance to see what happens. So I'll give you a moment, and now I'll do it. Okay, so we pull up on the plunger and we decrease the pressure. And what we should see is that our marshmallow is starting to fill up our syringe. It's touching the sides.
Yeah.
So you're decreasing air pressure in here, and that causes your marshmallow fish to swell up. Now, if you got a deep sea creature from the bottom of the ocean and brought it up to the surface, that's the same thing that would happen to them. Deep sea fish are used to being squashed by a lot of high water pressure. So when you reduce the pressure, when you bring it up to the surface without as much water squishing it, then it gets bigger and bigger and bigger. Now, if you've ever seen quite a famous picture of a fish called the blobfish, this is what's happened to the blobfish. So the blobfish is a deep sea fish, and when it's swimming around in the deep sea, it actually doesn't look particularly unusual. So it's swimming around like a normal fish. And then when you bring it up to the surface too quickly, then that's when it swells up and you get the classic photo of a blobfish with what looks like a big nose, and that some of you might have seen before. But we can do this the other way around as well. So if you pull the plunger up to near the top like this, and then again cover the end, then if you then push down, you should see the opposite effect. So you should see that your marshmallow fish gets squished. You're increasing the pressure. So we've put our deep sea fish back into our high pressure environment. And that is why you or me, Nadia, could not go down to the deep sea without some kind of protection, because we are not adapted to that environment. So that's just a simple way to see the effects of pressure on different deep sea creatures. Now, obviously, we did that with air pressure rather than water pressure with a marshmallow because we thought that would be a little bit less messy. And we've got quite a lot of cables around here, so we didn't want to risk too much water here. So that is our pressure in the deep experiment. Now, if I could pass this back over to you, Nadia, then I want us to think, because we're about halfway through now, and all we've talked about is the ocean. And this is protecting our ocean and ice. So now we are going to be connecting through to a polar scientist whose name is Roseanne. Now, Roseanne is in Antarctica right now, and hopefully we'll be able to connect up with her directly. So, Roseanne, can you hear me?
I can hear you. Can you
Wonderful.
hear me?
I can hear you. Very, very good. So, hi, Roseanne. Thank you so much for joining us here at POP23 for Protecting Our Planet Day. We've talked to Nadia a little bit about the ocean and how we can protect some species in the ocean, but we needed to go a little bit further away to learn about the polar regions. So we thought we'd get as far away as possible out to Antarctica. So, Roseanne, can you introduce yourself to everyone and tell us a little bit more about what you do?
Of course I can. So my name is Roseanne and I am a scientist with the British Antarctic Survey. And guess where I am right now? I'm in Antarctica. I'm on board a ship called the Sir David Attenborough, and I'm currently standing at the very top of the ship on the observation deck, and the windows behind me are showing a very, very foggy, cold scene of the ocean that surrounds Antarctica.
Amazing. So not necessarily the best weather over there in Antarctica, but what can you do? How long have you been down in Antarctica, Roseanne?
We've been down here for about a week or two now, and we have had lots of different kinds of weather down here. The temperature has normally been about 0 degrees, so about freezing points. We have seen lots of ice, and we have had lots of wind as well. But we've also been blessed with some gorgeous sunny weather, and we've even managed to see lots of icebergs sailing past our boats. And we've seen some whales, and we've even seen some penguins on the icebergs as well. So hopefully what we can do in a little bit is we will try and take you outside with our camera so that you can try to see the ocean, and you can maybe see some fog as well, that's for sure. And hopefully we might be able to see an iceberg or two emerging out of that fog.
I mean, that would be amazing. Fingers crossed, but yeah, we'll just see what the weather is like and what the icebergs feel like doing that day. So a reminder to everybody watching that you can pop some questions into the chat. I've got my iPad here and I can check some questions that are coming in so I can pass them on to Roseanne. But I'll start us off with a question for Roseanne from myself, which is, what research is it that you are doing down in Antarctica right now?
That's a really good question. Well, we've got lots of different types of science going on down here on this ship. One of the main things we're looking at is something called sea ice. I wonder if anyone has ever heard of sea ice before. Sea ice happens where the surface of the ocean gets so cold that it freezes to form ice. And that ice can be a few meters thick, so thick that you could walk along it. And every winter, the sea ice grows across the ocean around Antarctica. And then every spring, the temperatures rise and all of that sea ice starts to melt and break up. And that's one of the things that we've come down here to study on our ship, is what happens to the ocean and what happens to the animals living in the ocean when all of that sea ice starts to melt.
Okay, so what kind of things is it that you're measuring then when the sea ice is forming and when it's melting? What kind of changes might you be seeing?
Well, just like if you put an ice cube into a glass of water and that ice cube started to melt, you might notice that that makes the glass of water colder, because it's bringing the temperature of the water down. And sea ice does the same thing when it melts. So the temperature can actually decrease a little bit. And another thing that happens is that it changes the saltiness of the ocean as well.
Okay.
Yeah.
So how does it do that?
Well, the way it works is that when the sea ice freezes in winter, it basically doesn't want the salts in the seawater to be in the ice. Instead, it pushes out all of that salt into the water beneath so that the water beneath gets even more salty. And then when that ice melts in spring, it releases water that's a little bit less salty than the water underneath it. We say it's a little bit fresher. It's more like fresh water. And then that can change the amount of salt that's in the upper ocean. And it's really important that we kind of make measurements to understand this process, because the saltiness and the temperature of the ocean is what drives things called currents. And it's what changes and affects the structure of the water at the surface and further down at depth as well. So these are two things that we're always measuring.
Oh my God, okay, so my mouth was just like sitting open as I was like, what? That's so many changes that you're managing to measure just by looking at all of this information about sea ice, which is really cool. What kind of tools do you use to actually get some samples, either yourself or maybe on the ship as well?
We have some excellent tools on board this ship. We actually have a few of them that we can show you here today. So I'm going to bring my glamorous assistant, Katie, in to help with this.
Hi, Katie.
So this here that Katie's holding is called a Niskin bottle. And this is a bottle that we actually lower into the water off the side of the ship. And it goes down really, really deep, sometimes to 1,000 meters depth or even more than that. And it fills up with water, and then it traps that water inside the bottle so we can bring it to the surface, and then we can get a sample of the seawater from that depth. So that's a really useful tool. But we also have another very exciting tool that we can show you today.
I'm excited.
Which is something that we use to get some samples of the sea ice itself. Mm-hmm. And so the sea ice that I mentioned is that frozen crust of ocean at the very surface. But sometimes we want to go onto the sea ice crust and get a little bit of the sea ice so we can see what's inside the ice, and we can do some more science and tests on that ice itself. And we use a corer like this. This is called a sea ice corer. It looks a little bit like a twister lollipop, I think. And we basically put it vertically onto the ice, so it goes up and down, and then we use it like a drill to go down into the sea ice, and then we bring up a cylinder of the sea ice back onto the surface, and then we can carry that home. We have to keep it frozen, of course, because it's very cold.
Yeah, I mean, just like a twister ice lolly, I guess. Maybe
just
not
like
just like amazing. So that's some really cool equipment that you get to use. Now I've got a couple of questions that have come in from some schools that I thought maybe I would posit to you. So one of them is, do you need to look out for any animals that might hurt you? That came from P4 and East Craig's primary school.
Fantastic question. So we actually are quite safe down here in Antarctica. The main reason for that is because there are no large mammals on the land or on the ice. We do not have anything like a polar bear down in the South Pole in Antarctica. And that would be our main predator, if you like, that would cause us some risk. However, if we did go to the North Pole, to the Arctic, where we do find polar bears, we do have to be extra special careful up there, because polar bears can be very dangerous. And, they might be very curious as well, so they definitely would come up to us and say hello. So luckily, down here in Antarctica, we're pretty safe. We've got lots of whales and seals to see, but nothing that's going to cause us too much harm.
Yeah, I feel like a penguin would be a little bit less dangerous than a polar bear.
Definitely.
I'm not a polar scientist, but I think that's true. Have you been to the Arctic as well?
I have actually been to the Arctic as well. I was up in a place called Svalbard in April this year, and we had some gorgeous snowy scenes up in Svalbard. We had a little boat there, not as big as this one, it was much smaller, but we got to sail around and see some of the ice and the icebergs there as well. And it's an absolutely beautiful part of the world. I feel very lucky to have visited North Pole and the South Pole now as well. So that's two ends of the planet.
Yeah, amazing. And we've got a question here from St. John Vianney Year 4s, which is global warming obvious in Antarctica? And I suppose, is it obvious in the Arctic as well? And what are the signs?
Well, that's a really good question. There are lots of signs that global warming is starting to affect things that are happening in Antarctica. And that's very worrying because up until quite recently, Antarctica has almost been quite separate from the rest of the world. It's very far south. It has its own kind of cold climate and oceans surrounding it that have tended to keep it a little bit separate from the rest of the planet. But worryingly, we're starting to see some signs that this is changing and that the warming temperatures caused by human climate change are starting to impact the amount of ice that we have in Antarctica. And this is causing that ice to start to melt, and those warming temperatures are increasing the rate of melt. So that means the speed of melting. And this could have a really big impact for a whole range of different things, from the animals that live here, from the sea level, the amount of water in the ocean, and also to, many, many effects for the other kind of base of the food chain as well, and other animals that live down in Antarctica. So there's lots of reasons why we should be really concerned about this and keep monitoring and getting lots of data.
Yeah, no, absolutely. And that sounds really, really important. That also answers another question we had, which is, why do you think it's important for us to study the ice? I suppose because it has so many impacts and so many other things like food chains, food webs, and lots of different parts of the environment. It's not just the ice itself. Now, we've got a question here, which is from Wallastone Primary School, which is simply, what is the biggest tool you use in your research?
Ooh, the biggest tool that we research, I think the answer to that would have to be the ship itself. So we are on a very big ship here. Maybe in a second we can go outside and try to show you a little bit of it. But amazingly, this ship has been built by some very clever people to make it perfect for doing science in this extreme polar environment. And that means that they've actually been able to attach lots of instruments and lots of bits of kits onto the ship itself. So even now, as we are sailing through the ocean around Antarctica, we're gathering data all the time from these instruments that are stuck underneath the ship. So I think the ship itself is basically one giant instrument.
Yeah, I mean, I think that would count. And it's the RRS David Attenborough, isn't it?
That's right.
Yes.
So David Attenborough, yep, named after the man himself.
Yes, and it's the boat that didn't end up getting called Boaty McBoatface, is that right?
It was almost there, wasn't it? It was touch and go. We all hoped it was going to be called Boaty McBoatface, but it wasn't to be. Although we did save that name for another piece of kit that we have on the ship. We have a kind of robotic glider, which we decided to call Boaty McBoatface instead. So we do still have Boaty McBoatface on the ship, which is very good news for everyone who wanted that name.
The name survived. Now, I've got one more question for you, and then maybe we'll have a little bit of time to see if there's anything that we can see outside. So there's one question from Tiger's class at Riven Hall, which ties into something that a lot of people, including yourself, Nadia, might not know, which is that you and I, Roseanne, we worked together back in 2015, so it was before some of the people watching were even born, visiting schools and doing science workshops and stuff, so in Edinburgh and around Scotland. And I'm still in Edinburgh, and yet you are down in Antarctica. You've gone to the other side of the world, one of the most remote places. And so Riven Hall's question was, how did you get to be a scientist working in Antarctica?
Well, that's a really good one. And I think it's really important to say there's lots of different routes that you could take to become a scientist. And I took a bit of a wobbly, twisty-turny route into what I'm doing now. I loved science at school. I did chemistry, was one of my favorite subjects. I love looking at how things mix together in the lab. And then I decided to go to university and study more about the Earth around us. So that's what I decided to do. I did something called a degree at university, and I spent 4 years up in Edinburgh learning all about our planet. And what really struck me then was that the polar regions are extra special, in my opinion, because they are so beautiful. The cold is so sharp and thrilling when you're up here. It's absolutely stunning place to be. The scenery is spectacular. But more important than that, it's really fragile part of our planet. The ice is something that's so vulnerable to climate change. That means it's very sensitive to climate change. And it's definitely really important that we keep monitoring it and understanding how ice responds to temperature and how ice plays such an important part in our Earth system.
Yeah, no, I think that's a really great answer. Yeah, it's such a vulnerable place that even though it's so far away from us here at Dynamic Earth Today, as so far away from people across the UK, it's actually, well, I suppose the Arctic isn't actually that far away, but it's seeing these really severe effects. So it's good that we've got scientists like you out there researching what those effects are and trying to work out some solutions to what we can do. Now, we are just about having to wrap up in a minute or so, Roseanne. Do you think that we'll be able to see anything if you did try to go outside? Yes?
Let's go see what we can spot, shall we? I'm going to carry this with me. Here we go.
Okay, so a live tour.
Very big, heavy door out to the outside. There we go. Let's get onto the deck.
Amazing.
It's very windy out here.
Oh, cool.
And we're going to come around.
We can't hear you so well anymore, Roseanne, but we can see you.
Okay.
We can see you. It's just a little bit choppy sound, but I think it's worth it for being able to see the actual Antarctic environment. Oh, we can maybe hear you a bit better now.
Is that any better? Can you hear me okay?
Yeah, we can hear you now.
Okay. Now, we have some very small icebergs on the horizon there.
They're still icebergs. It still counts.
They are still icebergs. They're quite small. We have a few more over in this direction, so we'll come around. I'll see if Katie can follow me around here. Very windy down here as well, and that wind really adds an extra chill to our temperature. Definitely very important in Antarctica. But it's okay because we've got lots of layers on, and we are keeping very totally inside all those layers. So here we can actually see the back of the ship. If you want to put it down a little bit, Katie.
Oh,
Nice. Down that way, so you can see we're leaving a big trail behind us, foaming up all of the seawater. And if you're really lucky, you might be able to spot some iceberg in the distance as well.
We can just see those as well. You promised us icebergs, and you did deliver.
We have delivered.
Thank you so much, Roseanne, and thank you to Katie as well. So I think we'll wrap up our chat there. But thank you so much for taking time out of your busy schedule, researching Antarctica and talking to us about the work that you're doing. Now, to let everybody know, Roseanne and I had a chat a couple of days ago, which we recorded, which will be part of our STEM Clubs hour at 3:30. So if you want to learn a little bit more about some of the work Roseanne does and how they plan what they're going to do, you can tune in at 3:30 this afternoon. But for now, Roseanne, it is goodbye from us. It was lovely to see you. And we'll come back to the studio. So thank you so much to Roseanne for taking her time out of her day to speak to us. I thought that was amazing.
It was amazing, yeah. I learned so much.
So jealous that she's gone from Edinburgh. Edinburgh's lovely, but Edinburgh to Antarctica. Getting the opportunity to go to such a remote place is incredible. Now, we've got a few minutes left of our session, and what I thought we would finish on is a little bit of a quiz to try and get us thinking about some of the stuff that Nadia was talking about and some of the stuff that Roseanne was talking about as well. So it is a quiz which is called Science or Fiction. And in a moment you will see an image up on your screen, and we are suggesting some ideas of things that we could do to protect the ocean and to protect the polar regions. And some of them are real science that innovative, that just means creative scientists are coming up with, and some of them are just things that we've made up, okay? So you need to decide if what you're seeing is real science or if it's just fake fiction. And I'm gonna test Nadia on some of these as well to see what she thinks. So let's see if we can get our first picture up. Okay, so your first one is lowering sea levels by removing non-essential boats, animals, and shipwrecks from the ocean. Now, Nadia, does that sound legit to you?
I mean, it would decrease a little bit, but I think there's such a small amount, I don't think it's worth.
So you think it's fiction?
I think it's fiction.
Let's see. So You are correct, and well done if you got that at home. So I think if you just scooped everything out of the ocean, I guess like it would, yeah, as you say, make the levels decrease a tiny bit, but also then you're having to decide what animals don't need to be in the ocean. And I don't know if we can start going down that route. They're all pretty important. So, and that was our first one. There are 6 of these if you are keeping score. Okay, so next up, we've got adding seaweed into cows' diets, which reduces the amount of methane produced in their burps. Now, methane is a greenhouse gas, and cows produce a lot of methane because they chew the cud. They chew a lot of food, and it's a lot of gas builds up, and they burp, and all that methane ends up in the atmosphere. So, do you think we could add something into their diet to stop them from producing that much methane?
I mean, it kind of makes sense, but seaweed?
Yeah, it's not, doesn't seem like a natural thing.
It's not a normal thing that cows would eat, but I'm going to say, yeah, I think that maybe might be something that someone's trying.
Those cows do look at home on that beach, so let's see. You're right, it is science. So this is our first real bit of science. There are scientists who are studying some ways they can maybe alter cows' diets. So instead of just having lots of hay and grass and that kind of thing, they found that with some types of seaweed, add it into their diet and it can reduce how much of that gas builds up in their bellies and ends up coming out through their burps. So very, very clever indeed. Now next up, we're moving on to some ice here. So we've got covering melting glaciers with blankets that reflect sunlight and keep the ice underneath cool. Now, if you're not sure what a glacier is, it's like a big river of ice. So do you think you could put a blanket on top, keep it cool?
That's a tricky one, Chris. I mean, covering a river of ice with a blanket seems...
Got to be a big blanket.
It's going to be a big blanket.
Yeah.
I'm not sure if that one's true.
Oh, you think it might be fiction?
I think that might be fiction.
Yeah, well, we'll see what you think at home. This is science, which is pretty...
What?
Yeah, you would think it sounds made up, but there's a place in Switzerland where they have lots of glaciers. They were finding that as summers are getting warmer, they're losing a lot more ice than they were losing before. So it's normal for a little bit of ice to melt as it gets warmer around the year, but they noticed more and more was melting. So a lot of people who lived in this area decided, let's put a huge sort of white reflective blanket on top, see if the ice doesn't melt so much, and they found that they were right. It actually preserved the ice, although I don't know how long-term a solution that would be to just cover ice with blankets. And I don't know that Roseanne could do that in Antarctica.
No,
So.
a very big blanket.
But maybe we could have a bigger scale bit of research done in future. Now, here we've got covering mountains with artificial snow all year round to reflect more of the sun's rays. So similar idea, reflecting heat from the sun.
Surely that's not true. How would you get the snow up there?
That's true. You're getting to some very difficult areas to reach. So this one, you might have made your decisions. This one is fiction. So I think that's going to be one of the problems they face. I guess as well, if it's artificial, like if we were talking about any plasticky material, that would be maybe not a great thing to put into the environment. You'd have to find something that wouldn't do any damage to any of the ecosystems around there. So that one was fiction. Well done.
Redeemed myself.
You redeemed yourself, yeah. Not full marks, but. And we're on number 5 now. So, cooling down the ocean by dropping giant blocks of ice in every now and then. What do you think? That face suggests.
It sounds false, but with the blankets on the glaciers being true, I don't know what's reality. I'm going to say that's false. That's fiction.
You would be right. This one is fiction, but I've put a credit in there because this was a photographer who works for NASA. This is actually a real iceberg. Those are called tabula icebergs. Tabula, like a table, big and flat and kind of rectangular. So that is actually just a bit of ice that's just broken off Antarctica in particular here. So it looks like it's been made by people, but it just broke off. And we've got our last one to look at, spraying a compound called silver iodide into the clouds, making them thicker and more reflective.
Now, I think I may have heard of this one. I think this one actually might be true. Yeah.
And, well, you would be right. This is science. Now, this sounded a bit more scientific, didn't it? So it actually named a particular substance, silver iodide. It basically is sprayed into the clouds, and again, it's also to do with reflecting some heat from the sun. But the trouble there is that then you don't really know where those particles are going to stay. They might end up drifting anywhere if they're blown away. So, well done if you managed to get 6 out of 6. To be honest, if you got even any more than 4, I'm very impressed. So well done at home. Now we are almost out of time here today, but I hope you've enjoyed learning about the ocean from Nadia and about the poles from Roseanne, enjoyed doing some experiments and quizzes, and that you were inspired to look at how we might protect our planet, particularly our oceans and the icy parts of our planet in future. So thank you very much for taking part, everyone. I've been Chris. Nadia's been Nadia, and we'll say goodbye and maybe see you later.
Bye.
Bye, everyone.